Okay, guys, welcome to Unit 12, Day 1. Some of you are doing this without me, and for that, I'm sorry. I'm sure you will survive, though. We're going to look today at box and whisker plots as a warm-up. You've probably already done that. Then we're going to look at summation notation and mad notes, and that's not like angry, so don't get all in a panic, okay? I do want to take a look real quick at the box and whisker plot warm-up because I think that there are some points on it that I want to make sure that you guys have got. Hopefully you wrote down probably a lot more than I have. Obviously some big picture things I want to look at. Well, the biggest picture thing here we'll look at in a second. First, there's a larger range for caffeine. Range is distance between the lowest and the highest. There's a higher average for non-caffeine. Um, there are, I'm sure, some specific numbers that you guys got for mean and max and min and the lower quartile and the upper quartile and all that, and that's all great. The big picture thing that I needed you to know, and look, boom, star, big picture, okay, it's important now. It has a star by it, is that the non-caffeine people perform better. We should be able to look at a box and whisker plot and say, what knowledge can you gain from this data? And all of the specific numbers and everything like that tells us that people who did not have a caffeine drink did better than those that did. Okay? All right, so there's that. Let's take a look at this, the summation notation and MAD, mean absolute deviation notes. If at any point you need to pause it as we go here, that's fine. Just talk to the sub and ask the sub to pause it or go back. I'm going to move a little bit quick so the video isn't super long, so you may need to pause. Okay. First, summation notation is a mathematical representation for a sum of elements of a set of data. Okay, a sum of elements of a set of data. That's what summation notation is. Summation notation is also called sigma notation, after the capital Greek letter. Okay, it looks like this sort of funky looking E here. It's not an E, it's a Greek sigma. All right. To represent the process of adding a set of data elements, we write this, okay, this sigma, and there's an N on top and an I underneath, and then xi and all that. And what these all mean is the xi represents a specific term, okay, the xi represents a specific term. I represents its place in that set of data, so where it is. And the N represents the total number of elements in the data. Okay, pretty simple. So if we take a look here at the Jones family has 6 members, including Fluffy and Spot. I'm hoping those aren't kids' names, because if it is, those are some mean parents. So our N is 6. Their heights are the elements of our data set. Okay, so our data set is 65, 72, 70, 58, 22, and 28. This Greek letter down here is called mu. It's a symbol that means average. Okay, it's a lowercase Greek letter. Our formula for finding the mean looks pretty much like this, and this is a little bit more general than this is about what you guys need, okay? Mu, the average, is equal to the sum of all the numbers divided by how many there are. All right, so take a second, if you guys could please pause the video right here. Pause, somebody get up, press pause, hurry, 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 hurry! Okay, good, press pause, and you're gonna, hopefully now you've unpaused it, or maybe you still haven't paused it, I'm not sure. Find the average of that set of data. Find the average of their height. So pause now, find that out. Alright, so now you've unpaused, and hopefully you got the same thing I did, which was 52.5. Alright, let's take a look at the next page. So mean absolute deviation is a way to determine the blank, the variability, or the blank dispersion of a set of data. Okay, the variability or the dispersion of a set of data. Variability is how different something is. The dispersion is how spread out it is. Okay, so if you want to make a note somewhere, that's not a bad idea to add on, different for variability and spread out for dispersion. Okay. When we calculate the mean absolute deviation, we use it to give us a general idea of what is considered normal for that particular set of data. So we're trying to see how different or how spread out, how how relative the data is to itself. We're comparing it to itself. So MAD is often preferred by statisticians over its cousin standard deviation. I don't necessarily agree with that. There's different opinions on this, but it's just another tool. We'll talk about standard deviation later. It's less affected by outliers. Outliers, you guys know, are pieces of data that are way far away from the mean, or way far away from most of the other data. Okay. So there's a formula for mean absolute deviation. It looks incredibly complicated. Okay. I promise it's not. We're gonna learn how to do this. It's gonna be very simple. Okay. Step 1, find the mean. That's no problem. Okay. Step 1 is find the mean. Step 2, we're going to subtract the mean from each element in the data set. All right. Step 3, we're going to write down the absolute value for each of those differences. Step 4, we're going to add those numbers. And step 5, we're going to divide that sum by n, which is the number of elements in the data set. Okay, so we're gonna complete each step of for our set of data with the Jones family heights. Okay, so step 1, we already did that. We found that the average was 52.5. Step 2, we're going to subtract. So go ahead and take a second, pause the video here, and subtract 52.5 from each of those sets. Pause the video now, please. Okay, so you've unpaused, and where am I going? Oh, large arrow, and there. Hopefully you got all the same differences I did. If not, one of us needs to work on our minusing. There's a chance it's me, but I hope not. Step 3, we're going to write down the absolute value for each of those. So absolute value is just distance from 0. So these 4 are fine, and these last 2 become positive numbers. Okay. Step 4, we're going to add up those numbers. Go ahead and pause the video and add those up, please. Okay, you've added up those numbers, and hopefully you got 110. And step 5 is to divide 110 by the number that there are. So 110 divided by 6 is 18.3. I rounded, it's 18 1/3, but 18.3. So the big picture is, what does this tell us about the heights of the Jones family? So, take a second, pause the video, think, talk, whatever. What do you guys think this tells us about the heights of their family? Pause the video and discuss that for a second. Okay, you've unpaused. Here's what I think it tells us. I think it tells us the average distance from the mean is about 1.5 feet. Okay, so just real general, that's about 18 inches. So we're saying the average distance from the mean, the average distance from the average, is 1.5 feet. I think that tells us that there's a lot of variability. 1.5 feet is a lot, and it could go in either direction. So I think that tells us there's a lot of variability between the Jones family heights. Okay, that's it for 12B. Let's take a look at 12C. 12C is an activity. I would like for you guys to go through this activity on your own. Try and come up with answers. So pause the video now. You're going to go through this page and the page after, and then I'm going to go through the answers with you. So pause the video now, work through these 6 questions, and then unpause. Okay, by now hopefully you've unpaused. Let's get some correct answers. The answer to number 1 is line B has a larger mean absolute deviation. The average distance from the mean is bigger for B than it was for A. Let's take a look at number 2. Which one did you guys think this was? B again. Yes, you're correct. B has a larger, it's more variable. There's a larger dispersion. It's more spread out. All those different ways to think of it. Let's take a look at number 3. What did you think here? Yes, they're the same. Even though the mean here is lower than the mean is there, we're not looking at the mean. We're looking at the data in relation to the mean. Okay? Let's take a look at the next page. What do you guys think on this one? There are 4 here, 1 away, and there are 2 here each that are 2 away. Same. Okay? There's 8 members. N here is equal to 8. Here, N is equal to 4, and that matters. All right? Let's take a look at number 5. Plot A has a larger one. This outlier here really pulls that mean absolute deviation, makes it a little bit larger. Let's take a look at 6. Here, different number of n again, but the distance from the mean for both is 0. 0 divided by no matter what is still going to be 0, so those are both the same. Okay, great job getting through the notes. I would like for you guys to work your way through this worksheet, mean absolute deviation. You're going to do as much as you can of this in class, and then we'll do the rest. You'll do the rest for homework. Um, all these problems, it's practice doing this. There's a formula on the SOL. You get the formula. Go all the way back here. You get the formula for mean absolute deviation, but I think getting this formula is not exactly going to help us with figuring out what the mean. Sorry, I was lost there for a second. We get this formula right here, but that's not useful. That's on the formula sheet that I gave you guys. But being able to do these problems and figure it out, this will be good practice. This will help you. Okay, so you're going to work on this in groups together in class. That's fine, and then we will you'll finish the rest for homework, and we'll talk about these when we get back. All right. See you guys soon. Hope you enjoyed the notes. Bye.